tibial component, we don't have to worry about 6 degrees anymore. This is just going to be a flat 90-degree cut. So in the tibia, we're going to drill a hole down the tibial canal. Use our same intramedullary rod through our tibial jig. When we put the intramedullary rod down, we are now perfectly at 90 degrees. This cutting block is perfectly at 90 degrees in relationship to the tibia, which will then be perfectly parallel to our initial femoral distal cut that we made. With this depth cut, this is what we call a stylus. This will prepare our depth for us. We only have to take off 9 millimeters of bone, which is the minimum distance that we have to take off in relationship to the component that's going to get put back in. So this stylus will get us our depth. We want to make sure that our rotation is good, straight from front to back. We do the same thing, we pin it. Once that is pinned into place, we can disassemble. Again, we have a capture that goes on the cutting block that will help control the saw blade as it's running. Once that flat cut has been made, we can remove the tibial jig. At this point then, we need to size the tibia. When we size the tibia, we want it to be just the right size. We don't need it too big. If it's too big, it will overhang the sides of the tibia. And if it overhangs, then the lateral collateral ligaments will then rub on the outside of the prosthesis. If it is too small, then it will sit on the soft cancellous bone, and once the patient stands up and puts weight on it, the tibial component could sink into the soft bone. So we need it to be just the right size so that this tibial plate sits on the hard coracal bone all the way around the outside. And you can see the way the tibia is shaped. The component is shaped the exact same way. So once we find the right size that we want, and again this is a tibial trial, we will pin this into place and we will prepare Once that is in place, we use a punch for the keel. The keel on our tibia is the exact same thing as a sailboat. If you've ever seen a sailboat out of the water, it has a keel on the bottom of it which helps prevent a sailboat from getting pushed across the water from the wind. And this keel, same thing, will help support the tibial component from rotating or shifting inside the knee after it has been cemented into place. There's a stopper on this, so it can't go too far. And once that keel has been pressed far enough, this comes right out. Those pins in place. This is the plastic, so when the patient has the real implants in, it's a metal femur, it's a metal tibia with a poly spacer. And then, if everything goes well, these two components come together. And our alignment should be good and our stability should be good, so that our lateral collateral ligaments are even and tight on both sides. At this point, during a real surgery, we would be preparing to cement this prosthesis into place. So we would remove the femur, we then would remove the tibial component, and now your femoral cuts have prepared the femur. Your tibia is now prepared with the keel punched in the tibia and the femoral pegs prepared, so the real prosthesis would now be cemented into place. So in conclusion, we have prepared a femur and a tibia for implantation of a total knee. Keep in mind that a surgeon, most surgeons, about 75% of them, do femoral cuts first, then tibial cuts, and then they do the patellar cut. But as a scrub, if you have all your instruments in line, you are prepared for a surgeon who may want to do the tibia first, then the femur, then the patella, or the patella first, and then the femur, then the tibia. So if you have everything laid out in preparation, there should be no problem being able to switch gears and do one versus the other first. As we get ready to cement an implant in, this was the femoral trial that you saw that was in. So it's nothing more than a trial with holes that we drilled for the pegs. This is the real implant. So as the implant goes on, we put cement onto the femur, we put cement on the back side of the prosthesis, and then this will go onto the femur. You can see how shiny it is, and it is highly polished metal. The tibia, this was our trial, and we prepared the keel punch in the tibia. And then you can see what the keel now, this is an actual tibial component, what the keel looks like. And that helps prevent rotation of the tibia after implantation, and it helps it from shifting back and forth or side to side. So as that tibia then would then go in, and the plastic or the poly actually locks into that long term.